Hello everyone, welcome to this video. In this video, we will simulate the open circuit test for a transformer in order to determine the parameters of the equivalent circuit. So once you open MATLAB, so you will see these windows. So the current folder window, the details window, this is the editor window and the command window and the workspace window. So once the tab here is at home, so you come here to Simulink, you click Simulink, and then you click blank model. So we want to create a new model, and let's maximize this page. So this will be the space we will build our model. So as you see here from the library, we can collect the components that we need to do. For example, we need to have the linear transformer. So I'm going to the library, then here I'm selecting Simscape. And from Simscape, I'm selecting electrical. And from electrical, I'm selecting specialized power systems. From specialized power systems, I will select electrical machines. So here I have different machines. If you want to build a model with any of these machines, so DC machines, AC machines, wind turbines, and so on. So what I need to do is to go to sources, and I want from here to get the AC voltage source. So this is the first component that I want to use, is the AC voltage source. Of course, you can browse the library once again to collect all the components that we need, or you can use, you can double click anywhere in the model and write the first letters or words of the component that you want to select. So here I want to have the linear transformer, and here is the linear transformer. So this is the main component that we will perform the experiment on. So we are waiting for the linear transformer to appear here. So it takes time sometimes. So here is the linear transformer. And as you see in this linear transformer, we have a primary circuit, secondary winding, and tertiary one. So we need to have a two-winding transformer. So what I'm doing, I will double click here on the transformer, and I will uncheck this box. And the second issue that I need to do is to switch from per unit to standard international units. This is all what you need to do, and apply and OK. So as you see here is the transformer that we will use to do the open circuit test. Of course, we need to have some measurement units. So I'm typing measurement. We need to have a voltage measurement. We need to have a current measurement, and we need to have power measurement. So these are the three main measurement components that we need to have. So here is power measurement, okay? So for the power measurement, you need to double click, keep the frequency at 60 Hertz. And here you need to leave or to delete all the harmonic numbers and keep only one, which will be the fundamental component. And you click apply, then okay. So for the current measurement, it should be connected in series with the circuit. So here is the current measurement connected to the source. The other terminal is connected to the transformer. And here we connect the other side to the transformer. So let me make it a little bit like this. So it will be, let's say, nicer, a little bit nicer. Okay. So this is the primary circuit of the transformer. We need to have the RMS blocks, because we are using time domain representation. So this is the RMS block. By default, the RMS block is at 60 Hertz. So I will leave it as it is. And we need, of course, displays in order to show different values, measured values. So I need to copy this display and to print it, to paste it twice. I need 3 displays in this experiment. So one display is connected to the current measurement device. The other display is connected to the power measurement device. And the third display is connected to the voltage measurement device. So let me here flip the voltage measurement device. So right click, flip, and I will flip it, flip block left to right. Now I will connect the positive terminal to the positive terminal, the negative terminal to the negative terminal, and I also will flip this component. So flip, flip block, and it will be like this. Flipped, and we need to connect it to the voltage measurement device through an RMS block. So we need to have one RMS block. So copy and here paste. And we need also to flip it. So I will rotate and flip, and then flip block left to right, and I will connect it in this line. Okay, so this should show me the voltage, RMS voltage of the source. This should show me the current in the open circuit current, and this should show me the voltage. So I need to connect the voltage to the voltage measurement device before the RMS block, and the current to the current measurement device before the RMS block. So we need also to have power GUI block, and this power GUI block by default is instantaneous, and we keep it as instantaneous. Now the circuit is complete, so let's work on the parameters. So let's see what are the parameters in this transformer. So we have a voltage which is 735 kilovolt. So we need to have this voltage for the voltage source. And as you see, I will copy this value. And as you see, this voltage is RMS RMS value. And the frequency is 60 Hertz. So I will change the voltage here to be the same voltage. So paste, and as you see here, we have peak amplitude. So peak is larger by square root of 2. So I will multiply this value by square root of 2. So I will multiply it here by square SQRT of 2. So it will represent the maximum value of the voltage, okay? It represents the maximum value of the voltage. So I see something here extra, seems okay. And the phase angle, I will keep it 0. The frequency is 60. So I will do apply and okay. Actually, this is all what I need to do. Let me make the stop time equal to 1 second, and let me run the circuit to see whether everything is fine. So we see that everything looks fine. Here is the RMS voltage, which is 735 kilovolts, and here is the voltage measurement device. So the value here will be the open circuit voltage, and the value here will be the open circuit current. So it will be I open circuit, comma, measured in amperes, and this will be P open circuit, comma, measured in watts. And this one is the V open circuit measured in volts. So this will be V open circuit measured in volts. Okay, so this is the entire circuit, and I will run it again. So we see that we have the P open circuit value, the open circuit current value, and the voltage open circuit voltage value. And as you know, by definition, the open circuit test of the open circuit test, you need to apply the rated value voltage, the rated nominal voltage, to one side of the transformer, while you keep the other side of the transformer open circuited. So this is why we applied the rated voltage, and the rated voltage was taken from the transformer parameters. And as you see, we performed this experiment at the high voltage side. So the parameters will be the identified or calculated parameters will be referred to the high voltage side. And from these parameters, the open circuit voltage, the open circuit current, and the open circuit active power or real power, we can identify the magnetization resistance and the magnetization reactance. Here, we don't have the reactance, it is given as an inductance. So what you need to do is to multiply this inductance by 2 pi f by omega, which is 2 pi f. The frequency is 60 hertz. So then it will be xm. So you calculate Rm, you calculate xm, and you compare them with these given two values. It should be very close to these model values. So this is everything about open circuit test.